Hello guys, welcome back to our channel. In this video, we are going to make a project based on spam email classifier or SMS spam classifier. This classifier basically takes the messages as input and it classifies whether that particular message is spam or not. So let me show you the website first. This is my website, and I'll Google any a spam message over here. So spam message example. So let me select this, and when I click to predict, it already classifies it as spam. Okay, so how I made this website, we'll see it in detail. So for instance, I'm using Jupyter Notebook because it is very convenient to use. So there are 8 basic steps in our project. The first is data cleaning. We know that data is not always clean. Some values are missing, some columns are not so important, so we remove them. The second is EDA. EDA stands for exploratory data analysis. Then the third step is text preprocessing, then model building, model evaluation, improvement, website, and deploy. We'll see it in detail step by step. So first of all, I will import necessary libraries such as NumPy, Pandas, Matplotlib, and Seaborn. So first of all, we read the spam.csv. This is a file where many spam messages are there. I'll uh, I'll drop down the link of this CSV file in description, and encoding is in Latin one. Okay, so first of all, let's take a look on the shape of the data set. There are 5,572 rows and 5 columns in this data set. So we'll print first five columns in our of the data set. So we will get this V1, V2, unnamed 2, unnamed 3, and unnamed 4. These are the 5 columns, and there are 5,500 rows in our data set. If you take the look on the unnamed 2, 3, and 4 columns, many values are nan here. So to cross check, we can simply write here. So first of all, let's run it. To check here how many null values are there, we can simply write df dot is null dot sum. Okay, so as you can see, there are around 5,500 values missing in all the 3 columns. So our total number of rows are 5,572, and around 90% of the values are missing in those 3 columns. So these 3 columns will not be so helpful for our work. So we simply drop it by using the df.drop method. So after dropping it, we'll see that our 3 columns are dropped and only 2 columns are remaining. Okay, so there are no null values in the 2 columns V1 and V2. So we also have to check the duplicated values in the data set. So there are 403 values which are duplicated, which are not so useful for us. So simply we drop the duplicate values as well, and now the duplicated values are 0. So for our more understanding, we can and avoid confusion, we can replace V1 name of the V1 column by target and V2 by message. Okay, and we have kept in place equals to true. And also these this is ham and this is spam. Okay, so for our own understanding, we can uh, replace ham by 0 and spam by 1, because we have to perform some EDA operations on this column. And if we kept like ham and spam, it would be a bit difficult for us. So that's why we have replaced ham and spam by 0 and 1. 0 means ham and 1 means spam. And we have replaced v1 v2 by target and message. Okay, so let's see an example message. Here is a message: I sent you something something and bucks. Okay, and see, we have replaced the target of we have replaced the ham and spam by 0 and 1, but we have not changed the data type of it, because earlier the data type was string, but now we want int data type here. So we are simply converting that target column into integer type. So now let's take a look, and let's check how many of the messages are spam and how many are ham. So for that we have simply plotted a pie chart. So from pie chart we get an insight that around 88% of the messages are ham messages and around 12% are spam messages. So we get an insight that the data is not imbalanced. Data is not balanced. It is imbalanced because uh, ham and spam are not in equal proportions. Okay. So now we need to add some features. Uh, so now we need to add some extra features from our own. So, what features can we extract from the message? We can we can tokenize these message into words and count their length of sentence, length of words, like that. So for that, I'll show you. We have simply imported a library called NLTK. What NLTK does is it simply uh, tokenize the word and tokenize the words, which is helpful for us for finding for creating new features. Okay, so simply we have created a new column name word underscore length, and in which we have simply, what this function does is basically it tokenize all the whole sentence into words and counts their length, and it is saved in the word underscore length. Okay, then df of sent underscore length, we have created new column name sent underscore length, which calculates the number of the count of sentences in a particular message. Okay, so for instance, if we check the sent underscore length column, we simply get a series of elements. Okay, so now this is the most important part. We will now take a look on the description of the variables. So here, this is a target column basically. This is an num underscore char which we have created recently. Then word underscore length and cent underscore length. Okay. So num underscore char is basically the count of characters in each of the message. Okay. Word underscore length is the number of words in each of the message, and cent underscore length is number of sentences in each of the message. So if we take a look on the mean for number underscore character, each each of the basically the average number of characters used are 78 characters, and 18 words are used on an average, and approximately 1 point approximately length of the sentences is 1.96. Similarly, we can get other information too, like minimum 25th percentile, 50th percentile, 75th percentile, and max. Okay, so now let's check the description for number underscore character, word underscore length, and cent underscore length for ham messages. So in case of ham messages, approximately 70 characters, uh, number of characters used are 70 on an average. The word length is approximately 17, and cent underscore length is 1.8. Okay, and maximum 910 characters are used for ham messages, 220 words are used in a message, and 38 sentences are there in the message on max level. Now let's check for spam. For spam, the on an average 137 characters are used, 27 words are used, and approximately 3 sentences are used within the message, and maximum 224 characters are used here, 46 words and 9 sentences are used. So if we plotted a hist plot over here, we get that most of the messages have less number of character, and more number and for so basically this blue graph is for ham messages, and this red graph is for spam messages. Okay, so we get that spam messages have more number of characters as compared to ham messages. Okay, so simply we can also check for word length. It shows similar graph, right? So this graph was number of characters, and this graph is of word length. Okay, so both of the graph look similar. So what we get insight is most ham messages are made from less words, more spam messages are made from more words. So after it, we have to do some text pre-processing. So go if we go towards the message example, for example, this is a message I sent you. So now there are many uh, unnecessary words which are not so useful, like punctuation marks like ampersand, then a semicolon, etc. So we have to remove that, and we have to convert all the words into lowercase. So what we are going to do, first of all, we are converting uh, every s- every so we are converting every message into lowercase. Then we are going to tokenize it. Then we also remove special characters in it, remove stop words and punctuation, because these are not so useful for us. Okay. And stemming, what is stemming, I'll explain it further. So for transforming the whole text, I have made a function. So for that, I have imported string. Then I have imported porter stemmer from NLTK. Also, I have imported NLTK.corpus and imported stop words from there. Okay, and I have created an object of porter stemmer. So I have made a function transform text, in which parameter is text. So now uh, we have to first lowercase all the message. Then we have to tokenize every word. So now we have simply created a null list y. So for I in text, if I dot is al num, then y dot append of I. What this does is, if uh, if the function finds alphanumeric characters within the list of elements, it will simply append it to the y list. And simply we have cloned this list to the text. Text is basically the list, because nltk.word underscore tokenize returns a list. Okay. And simply we have cleared y. So now again we will run for loop for I in text. So if I not in stop words dot words and I not in string dot punctuation, then y dot append of I, then append of I. So what this tells basically, if there are no stop words and no punctuation within the list, then append that particular word in I. Then again we have cloned y here to text and simply cleared y. Okay. So again we will uh, run a for loop for I in text, y dot append ps dot stem of I. So first of, let's understand what is stemming basically. Let's take an example. Let us suppose there are three words: dance, dancing, and danced. So all three words, the main word, the root word is dance basically, is it? So what what stemming does is, it basically converts all these three words into a single root word. So here root word is dance. Okay. So it will convert all these three words into a single root word. So simply I am returning a string, return dot join y. Okay. So now let's create a text transform column where we apply our function transform text. Okay. After applying transform text, we have created text underscore tnf. This is a column basically. And see now, all the punctuation marks are gone, all the stop words are gone, all the words, every single words has came to its uh, root word. Okay. So now I want to see that which word out of the column are most frequent words in ham also and in spam also. So for it, I have simply plotted imported word cloud from the class word cloud and created the object. I've set width height to 100, minimum font size as 10, background color as white. Okay, so this is the code you can refer. So what can we see is this is these are the most frequent words from s- spam messages. These are the words call, text, txt, mobile, free. So what we understand from this particular you can say image is that these are the words which are most frequent in the spam messages. Similarly, we can also check the number of which words are frequent in ham messages. So these are the words, guys: want, come, go, think, need, know, etc. Okay, so this is for just understanding purpose that which words are most frequently used. Okay, so now we are going to uh, move towards our model building process. So from sklearn dot feature extraction dot text, we have importing a TF-IDF vectorizer. TF-IDF vectorizer is basically it converts uh, it converts every words into numerical into numbers basically, because the algorithm like knife base cannot handle the text data. In fact, no algorithm can uh, you you know uh, work on text data. So that's why these texts are converted into numbers and then it is given to the particular algorithm. So this is knife base. We have imported multinomial knife base from sklearn.model selection. We have imported train test state and related metrics. Okay, accuracy score, precision score, and confusion matrix. So we have simply created an object of TF-IDF vectorizer and we have set max features to 3000. Okay. Similarly, we have created an object for multinomial knife base. So now what we have done is we have uh, fit we have applied the method fit underscore transform on text underscore transform and I want to return an array basically. Okay, so basically the shape of the array is 5169 and simply we have created uh, an array of target values as well. So basically our output is y. Okay, we are expecting the output as whether the message will be ham or spam. So now we simply did train test split and we have kept random state as 2 and text size as 0.2. So simply we have fitted our uh, you can say x train and y train. We have used multinomial knife base here. Okay, so similarly now we are going to check the precision score, accuracy score, and confusion matrix. So here we what we got, guys. We have got 97% accuracy, and this is the confusion matrix. And the most important in this uh, particular work is that we have got 100% precision score. We have got precision score of 1, guys, and here precision score matters the most than the accuracy score. So now we are done with our uh, project. Or the only thing we need to do is deploy it in Streamlit website. Okay, so for that I have imported the pickle, and we have simply dumped the pickle to pickle named open vectorizer.pkl and write binary. Similarly, pickle.dump mnb open model.pkl. Okay, why we are using this pickle is we cannot directly take the input from this and deploy it to the server, because the server will not get input. Okay. Okay, guys, so let's move to our important process, that is website creation. So for instance, I'm creating website using Streamlit. Streamlit is a library in Python which in which you can easily make any website without writing the full front end code basically. Okay, so for that I've created an sms underscore class Python file in the same folder. Okay, so we have imported Streamlit, we have imported pickle, imported string, NLTK, and those related libraries. Okay, and we have created an object of portal stemmer. So now we will load the pkl file and we'll open vectorizer.pkl and read binary. Similarly, we have created model. We have created an object named model, which loads the pkl file of model.pkl. Okay, so st.title sms classifier. We have kept. So to view this website, you need to do is simply go to the particular folder. This My folder is spam messages. Then go to show more options, then go to open in terminal, and then simply run this syntax streamlit run. Then what the name of the Python file, sms underscore class, sms underscore class dot py. It will redirect to a local host on Chrome. Okay. It will take some time. Some error have came. Oh, okay. I have not executed. I haven't executed the full cell yet. So restart the kernel first, because the model.pkl and vectorizer.pkl have not been created because I haven't run the whole cell. Okay, so wait a minute. Let's rerun. Okay, so our vectorizer.pkl and model.pkl have generated successfully. So now let's rerun our website. I'll tell you how I made it. First of all, check. Yes, yeah, it's working. So let's go towards our code. We have simply wrote the title st.write. We have taken the input from st.text underscore input. So if you don't know how to uh, what are the methods in Streamlit, you can check the Streamlit documentation by googling it. We have taken input of the messages in the object input underscore message. Then this is the same transform function which I have used it earlier. Maybe this is the function, guys. This is the same function I have used in my Python file. What this function do is basically it filters out the unnecessary content from our file text. Afterwards, so we have created a button here, predict. So if st.button is pressed, if input message is null, then show a warning that please enter a message. Else, transformed as transformed SMS equals to transform text input SMS. Okay. So now we'll transform, will pass, uh, will simply convert all these words into a vector input by using TF-IDF class object TF-IDF dot transform, and we have passed the list inside here of transformed SMS. Okay, and at last we have predicted the result vector input of 0. Okay, because it is in tuple. So now simply, at last we have displayed, if result equals to 1, then st dot header is spam, else st dot header is not spam. Okay, so now this is the whole code, guys. So let's rerun the file. Yes, if we rerun the file, it will take some time, and simply we can take any messages from Google. Let's say this package and delivery. So we have pasted it here and we simply click the predict. Okay, so this is not spam, guys. Okay, and let's check for the for some spam messages. Let's check for this congratulations phishing link, and let's paste it here, and this goes to the spam. One thing to mention, that this spam classifier is not do not always show the correct classification, because at last it's a ML model, guys. So use your observation also, because the accuracy is 97%, not 100%. Even though precision is 1, uh, we need to try more on increasing our accuracy of model. So this was the project, guys. If you liked my project, please subscribe to our channel, as this is the first ML project I have explained. So please support, guys, and thank you very much.